Okay, so I've got a copy of the 2025 Foundation Maths paper. I'd like to give it a crack and walk through some of the problems, maybe divided into two videos. So let's have a look at the multi-choice questions. Question 1. Fuel cost 191 cents per liter, that is $1.91 per liter. A truck uses 35 liters of fuel per 100 kilometers of travel. The cost of fuel for 420 kilometers trip in this truck. Okay, so I'll try to figure out, let's say, the amount of money to spend on 100 kilometers. That'll be 1.91 multiplied by 35. And then I can say it has a correspondence to X dollars. Then this is for 100 kilometers. Then I can construct, let's say, 420 here. So this is actually a ratio relation. For example, I can say 1.91 times 35 divided by X. Or I can actually use X divided by this number, but doesn't matter, equals to 100 divided by 420. Therefore, if I want to figure out X, I can say X is 1.91 times 35 times 420 divided by 100, something along this line. And then I can use my scientific calculator. Even though I've only got a CAS calculator here, I'm not going to use, let's say, some advanced functionalities. 1.91 times 35 times, let's say, 420 divided by 100. So I'm going to get a decimal answer, which is $280.77. So option D. Okay. A wall is constructed using 420 bricks. The cost of one building brick is $1.31. An estimate of the total cost of the wall is made using the cost of $1.50 per building brick. We would like to find the floor value for the percentage error. So firstly, the percentage error is 1.50, that's the estimate value, minus the actual value, divided by the actual value. Then I multiply by 100%. So I'm trying to calculate a percentage, and then I can just use my calculator. 1.5 minus 1.31 divided by 1.31, which is my base number, multiply by 100 and convert to, yep, this is 14.5038 something. Well, it looks like we need to choose option D because option D is closest to the calculated value, but the question has bolded this phrase, the floor value. So for value, we could have, let's say, a ceiling. We could have a floor, okay? So if I correct this number to the nearest percent, I know 14.5% is between, let's say, 15% and 14%. That's why the floor value should be rounded to, let's say, option C, 14%, which is like the lower limit. Okay, question 3, the graph below shows the recorded daily exchange rate for the Australian dollar compared with the United States dollar for January 2025. So we would like to find the largest decrease in the exchange rate. Okay, so if I look at a decrease, 7th and 8th January is like this line segment, and 8th and 9th January is like the second segment here. 12 and 13, it's like that. And the last one is 27th and 28th January. It's like the last segment here. So comparatively speaking, I would say option C or option D would be showing the largest drop. However, if you look at the values closely, what I would suggest is you use a ruler. You use a ruler to, actually locate the values, okay? Locate the values. So for example, if you look at, this dot here, you could actually draw a line. And then let's have a look. This will be, let's say, 0.6, I should say 195, because it's the middle of these two small grids. And also, if you use another ruler here, like draw a straight line over there, I would guess this is 0.61 and 3. Also, if you do a similar thing to, let me just use the ruler again. Well, this is not a proper ruler, but yep. It does the job. So for example, use the ruler to align, this point to the scale number. You'll be able to get, let's say, 0.6315, maybe something along this line. And then you can just move the ruler over there, which is along the line of 0.625, okay? So I'll be doing two calculations. For example, for the blue segment, I will have, 0.6315, take away 0.625, something along this line. And comparatively speaking, I would say, well, because this is an estimation, maybe I can, just get a calculator to do the job. 0.6315, subtracting 0.625. So this value is 0.0065. Okay, now if you look at the other one, well, to be honest, the largest decrease, I would say it doesn't show much difference, unless I say this value is 0.632 something. Then I might get, let's say, instead 0.0070. Whereas if you look at, actually, I know this number should be slightly higher. Let me just draw the line again. Yep. So this value should be actually higher than 0.613. I would say 0.6135. Yep, something along these lines. So I'll calculate the change. Yep, I would say if we take an accurate measurement to the vertical distance whatsoever, then I would say the last option gives you a slightly larger gap in the vertical direction. That's why I prefer option D as the answer, but you will see eventually the acceptable answer published by VCAA, because VCAA hasn't published the assessment report for this paper. Okay, question 4. In 1901, Australia had a population of 3.8 million people, and 2023 had 26.8 million people. We want to find a percentage increase. So the larger value subtracting the small value, use the small value as a base number, multiply by 100. I believe it's close to option B, if I'm not mistaken. You can use your calculator to do that. Yep, that is question 4. Question 5, a section of the rail of a bridge is shown in the diagram below. It is constructed using a set of similar triangles. 3 of them are shaded. So the H is the height of the largest triangle. The smallest triangle has a width 4, and the largest triangle has a width 9. Therefore, similar triangle, we can use the ratio larger side divided by smaller side, and a larger height divided by a smaller height. Therefore, H is 9/4 multiplied by 2.5. And 9/4 multiplied by 2.5, something along this line. So you get a 5.625. Option C. Question 6. It is suggested that mortgage repayments should be at or below 30% of a person's after-tax income. A person's earning an annual after-tax income of $74,752. Okay, the maximum monthly mortgage payment. So you can either do 74752 divided by 12, then multiply by the largest percentage to figure out the largest monthly payment. So for example, 74752 divided by 12 multiplied by 0.30, that is 30%. So you get 1868.8. So that is the maximum monthly payment. Or you could actually figure out the annual payment amount, like multiply these two. But don't forget, once you multiply these two numbers, you need to divide it by 12 because it's asking for payment per month rather than payment over the year. Okay, a creditor needs a mean or average run score of at least 75 from 5 games to qualify for a competition. His run scores in the first 4 games were 68, 70, 72, 82. So the last one is missing. We'll call it x equals to something. Therefore, we have 68 plus 70 plus 72 plus 82 plus an x divided by 5. Should be at least 75. Well, I don't want to use inequality here. We can just simply use an equation equal to 75. And we can calculate this cluster and also multiply this whole equation by 5. So for example, the cluster I circled will be 68 plus 70 plus 72 plus 82. And that is 292. And also 75, the desired average multiplied by 5. Which gives a total 375. 292 plus x equals to 375, okay? And then you can identify this x value to be 83. Just use the 375 to subtract 292, you get it. Question 8. The Australian resident tax rates for 24-25 financial year are given in the table below. So, an experienced worker received an annual taxable income of $146,700. And this is in the category of here. It's larger than $135,000, but less than $190,000. Therefore, to calculate the taxable income, we would get, let's say, 31288 plus 37 cents, which is 0.37 in dollars, multiplied by the amount over 135,000. Therefore, we would have, let's say, 146,700 minus 135,000. We can just type this chunk of calculation into the scientific calculator and get the answer. For example, 31288 plus 0.37 multiplied by 146,700 minus 135,000. Therefore, you would get a 35617. Option B. Okay, so that's question 8. All right. A hospitality employee works 17.5 hours in a given week. Paid a gross rate of 25.80 per hour. Well, I believe that's slightly higher than the minimum wage. Geez. 17.5 times 25.80 and a superannuation guarantee multiplied by 0.12, which is 12%. So we can just do a calculation. 17.5 multiplied by 25.8, the hourly rate, multiplied by 0.12. And then the superannuation amount, the super amount should be 54.18. Option A. Question 10. A floor tile is designed in the shape of a rhombus. The diagonals separate the floor tile into 4 identical right triangles as shown below. The side length of the floor tile is 16 centimeters. The shortest length of each triangle is 8 centimeters. We want to find the area of the floor tile. So, because this is a right angle triangle, I'm actually calculating, say, the other side. So let's call it x. X equals to 16 squared minus 8 squared under the square root. I believe your scientific calculator can deal with that calculation. Maybe, especially like the either Casio one or the Texas one, TI-30. But anyway, 16 squared minus 8 squared, that gives you 8 root 3, something along this line. And then, because this is also x, we can treat, this one as half of the area. Half of the area, let's say it's half times 2x times the height 8, which gives you, let's say, 8x, and 8 lots of that is 64 root 3. So the total area equals to 2 times 64 root 3, and it's 128 root 3, which will give you 128 root 3, 221.7. Option B is the correct answer. Of course, if you recognize the triangle, the right angle triangle here in a ratio of, for example, this is 1, this is 2, this is root 3, you can identify this is a 30 degrees. Well, yep, you can do that. And this is 30 degrees. The whole thing is 60 degrees. So there are, let's say, 2 equilateral triangles. You could actually do 2 times half times 16 squared, 16 times 16 times sine 60 degrees. Then you can still get, let's say, 128 root 3, which is rounded to 221.7 centimeters squared, okay? Or you might want to use Heron's formula to calculate, let's say, the area of each triangle and then get the total. So that's question 10. Question 11. The area of a park is approximated using a rectangle as shown below. Using the given scale, the approximate area of the park. Okay, so my idea is you need to have a ruler. From my observation, this whole paper, at least 5 to 6 marks are related to your accurate measurement. So you need to use a ruler to get your job down smoothly. For example, if you use a ruler like that, or set square, plastic triangle, you can actually measure, for example, the length here and divide the length into, let's say, roughly speaking, 5 pieces in the horizontal direction. And then if you used roughly the same scale over there, it's 1, 2, and 3, okay? So that's, let's say, 3 pieces. This is like 5 pieces. Eventually, you can just break, let's say, the rectangular park area into, this is a crappy, drawing, but you get what I mean here. You have, let's say, 15 identical pieces, identical squares. So each square has 20 times 20 equals to 400 kilometers square. Therefore, 15 squares equals to 15 times 4,000. I believe it's 6,000. But the question didn't provide you, let's say, exactly 6,000. Therefore, we're going to choose option C as the closest answer, okay? Not sure if that's intentional, but yep, the closest answer is 5,400. I heard from other teachers and colleagues who are teaching foundation math, sort of a bit complaint on this question, but let's crack this question altogether. Long-term data trends for the movement of traffic on two major roads were analyzed and used to predict the likelihood of heavy traffic. The data showed that the heavy traffic occurred on Road A on 4 out of any 5 days. So, Road A, heavy. Road B, heavy. Not heavy. Not heavy. Right. These two things are independent, so I shouldn't, let's say, combine them all together in one tree diagram. So there are two, let's say, parallel lines. They are not joined together. We can't put a half and half there. But I do know this is 4 out of 5 days. And the other thing is on Road B, 3 out of any 5 days. Okay, the flow of traffic on Road A is independent of the flow of traffic on Road B. So we like to find the likelihood or the probability of a car encountering heavy traffic while traveling on both roads. This is an interesting way of phrasing, but my understanding is, if you recall from your year 9 or year 10 math content, if we want, let's say, the probability of A intersecting B, we could use probability A times probability B. I believe that's the intention. Therefore, probability A heavy road is 4 out of 5 times probability B heavy road, heavy traffic. I will get, let's say, 12 out of 25, which is 0.48. Notice the word independent here means you need to multiply these two probabilities. Okay, so that's option B. An interesting question. I wouldn't normally expect that on a foundation math paper. More likely, as a year 11 math method question. But anyway, bleach and water are mixed to form a cleaning solution. 2 parts bleach, 13 parts water, therefore total 15 parts. And a bleach, the proportion of bleach is going to be 2 out of 15. And the proportion of water is going to be 13 out of 15. Now, out of 60 liters, suppose this solution is well mixed, uniform, then I would say the volume of bleach is going to be 60 times 2 out of 15. Therefore, you can cancel this down to, let's say, 4 times 2, and that's 8. 8 liters. So that's question 13. A company sells candles for $15 each. The total cost of making the candles included a fixed cost of $1,500 plus $10 per candle. This information is shown in the graph below. Okay, right. Classic, linear equation, and also say break-even point, I would say. Yep, I think that's the intention. This is another place I'm going to mention the use of ruler. If you align the edge of the ruler along the sales straight line and extend that line further, also rotate your edge of the ruler and extend the dash line, you will eventually find a point of intersection here. And that occurs when the number of candles is 300. Therefore, break-even point for the cost equal to the not profit. Cost equal to the revenue or expenditure. 300. You can actually do it by algebra. For example, the cost will be 1,500 plus 10 times how many candles you sell equals to $15 times how many candles you sell. Eventually, you get 1,500 equals to 5n. Therefore, n equals to 300. That is another valid algebraic method. Okay, question 15. The percentage change in the cost of a selection of food items has a direct variation with reported inflation rates. That's an interesting way. The following table shows the price of some food items that were purchased in 2 consecutive years. Bread, 1 loaf, milk, 1 liter, bananas, 1 kilo, fish, 1 kilo, pasta, 1 kilo. All right, the reported inflation rate for the selection of years are given in the table below. The percentage increase in the total cost of the purchased food items from year A to year B is best reflected in the reported inflation rate for the year. No idea, but we can sort of guess the intention based on the information present in front of us. For example, you can see the year B prices are higher than the year A prices. Therefore, for example, for the first row here, I can calculate 4.28 divided by 4.20, and we should get a number. From my previous working, I got a 1.0190, something along this line. Well, this is calculating, let's say, okay, the new percentage against the old, let's say, price. Then we can say 2.08 divided by 2.00, 3.56 divided by 3.50, 6.80 divided by 6.70, 2.54 divided by 2.50. Calculating 5 ratios. I know these 5 ratios are all greater than 1. And then I probably can show you some specific calculations like 4.28 divided by 4.2. But I remember, you are trying to figure out, let's say, an overall inflation rate. Therefore, once I figured out the 5 ratios, I will add them up and divide it by 5 to figure out an overall, let's say, inflation rate, or I should borrow another term from general math. That is called seasonal index. Very similar idea, in my opinion. So let me just complete the calculation here. Plus, let's say 2.54 divided by 2.5. Now I get a total, and then I would divide this total by 5. Then this is 1.02 something, okay, 1.0214 something. Add up, divided by 5 to get 1.02, etc., etc. Well, if you convert this ratio into as a percentage, you get a 102 point whatever it is, 14% Therefore, combining everything together and take the average, the inflation rate should be, let's say, around this value according to the 5 items. And the closest number, I believe, is 1.90. Okay, you can see 1.61 is a bit off, 0.85%. Also too far away. 2.86, well, if you calculate the difference, this is too much, this is too much. So I would say 2018 would be the desired answer, in my opinion. Okay, anyway. Question 16. An office floor of 272 square meters is to be covered with carpet. A row of the carpet is 4 meters wide. Okay, 4 meters wide. Do you notice this 4 here? So if I want to install, let's say, the carpet, I can put a smaller or shorter row here and get it rolling this way, okay? And also there are 8 meters remaining, so I can divide the 8 meters into 2 parts. This is 4 meters, this is 4 meters. So I put another thicker or longer row going along this way. And another one going this way. The cost of the carpet itself is $89.99 per linear meter. 1 linear meter of carpet takes 20 minutes to install. That is, let's say, 1/3 hour. And each hour costs $80.50. Therefore, I can calculate the cost for these two. So 2 times 89.99 times, let's say, 24, because the linear meter goes that way, okay? Goes that way. And we can add the time cost, which is 2 parts multiplied by 80.50 times 1/3, and we multiply by 24. Well, for the shorter part, we can just do 89.99 times 20 meters. It's 24 less 4 meters. These two sides are equal to each other. Multiply. Do I need to multiply anything? No, not multiplying anything further, but we add the time cost to install this shorter row. So we have 80.50 multiplied by 1/3 multiplied by 20 linear meters. Eventually, we can add up the red numbers and the blue numbers, which I believe you should get from my previous calculation. I did this question before. 7299.986, if I'm not mistaken, and it's closest to option C. This is a very good question. Real life example. Question 17. The image shown below is viewed in a rear view mirror. Okay, just out of curiosity, MA103 is the VCAA code for foundation mask. MA07, like 072 stands for general math or further math in the earlier time, exam 1. And MA073 stands for actually general math exam 2. And we also have, let's say, MA112 and MA113. That's for math method exam 1 and exam 2. And finally, my most favorite subject, MA092 and MA093. They stand for specialist math exam 1 and specialist math exam 2. You probably don't know if you're just a student. There was another MA code, but it's never used again. In the older time, they also had MA08. That means it was the subject code for mathematical methods, no CAS, prior to, let's say, 2011. Anyway, that's a bit history. So, if the mirror, this is the mirror, we put an A here, we write the number 1 in the opposite direction, flipped or reflected. This O is still an O, but the 3 is reflected. Okay, something along these lines. So that is the mirror image of MA103. Okay. Question 18. A survey of 1,250 Australian residents was conducted to seek their opinions on the conservation of the Great Barrier Reef. The infographic below displays the results. Of those surveyed, how many? 1,250. Number who are deeply interested in the conservation of the Great Barrier Reef. Deeply interested. How much? 60%. So 1,250 multiplied by 60%. You can just get your calculator. You'll get a 750, I believe. Option D. All right, 2 more multi-choice questions. A credit card charges simple interest of 20.99% per annum for overdue account balances. An account holder's balance at the end of the given statement period is 2,750. 23 days of simple interest. Now, be aware. How they calculate the interest? simple interest. In a year, we use 365 days, okay? So if you delay the payment by 23 days, they're gonna charge you the interest by this proportion. 23 out of 365 multiplied by 0.2099. This is the percentage interest rate written as a decimal. And you multiply by 2750. So this part is your interest. Plus the overdue balance, because you can't just pay interest. The question wants you to figure out the total balance and interest amount. So you can use your calculator and do the calculation here. 23 divided by 365 multiplied by 0.2099 multiplied by, let's say, 2750 plus 2750. Yep, let's have a look. 2786.37. Option B. So in future, if you don't want to pay the interest, make sure you notice the, control your spend on your credit card, okay? Question 20, the graph below shows the Australian personal savings percentage from quarter 1, 2022 to quarter 3, 2024. Notice that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns, or actually 11 data values or percentages. We would like to find a median. In order to find a median out of the data set, you need to figure out the middle, ranking them from the lowest to the highest. So for example, this is the lowest, slightly higher, slightly higher. Where is the next higher one? Well, I would say it's here, 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 7th, 8th, 9th, 10th, 11th. So from 11 data values, you would say, okay, it's 11 over 2, which is actually 11 plus 1 over 2. That is 12 over 2, which is the 6th. So it's here. Quarter 4, 2023. Okay? So make sure you read the question. 2023, quarter 4. Not, let's say, the other columns. All right. That's it for the 20-minute choice question. I'll find another time to do a recording on the section B. There are other 60 marks worth questions. Totally 12 questions to go through. See you next time.